Good morning. One more hydraulic structure, very important hydraulic structure. I missed, sorry. That is siphon well drawn. Siphon well drawn. Usually in tank irrigation, across the bund of the tank, you can see siphon well drawn. It is similar to tank sluice with the tower head. So water will be flowing through RC Hume pipes, series of RC Hume pipes of definite length will be connected together, joined together, and those joints will be supported by small supports. From the upstream side, there will be an upstream well, then the pipe will be connected to that series of pipes connected, then there will be a downstream well. That is a setup of a siphon well. So water will first fill the upstream well, then go on pressure, pipe running full. So go on pressure, flow is by pressure, then gradually get elevated. The water level will increase at the downstream side. So there will be a downstream well also. There will be a notch which will measure, which will quantify the water discharge. So in the upstream well, you will have a notch which you have seen in the case of canal drop. Here also there will be a notch we have seen. Well, through the notch, the water will fall into the upstream well. Then, once water gets filled, pipe will be running full. That water will come to the downstream well. From the downstream well, it will go to the water stream or the canal or even to the agriculture land. So that is also an important thing. Siphon well drawn. Now we will just see what irrigation aims at. Irrigation, as you have seen, aims at irrigating, supplying water at regular intervals according to requirement of crop throughout the season. The area to be irrigated by a particular unit of irrigation is called ayacut, A-Y-A-C-U-T, ayacut, or command area. Command area or ayacut. Ayacut is the area in hectares to be irrigated by a system of irrigation unit. It is called ayacut. The region where complete irrigation takes care of the water supply, then I told you it is arid region, A-R-I-D, arid region. Semi-arid region is partially irrigation helps, the remaining will be the rainfall, direct rainfall. Irrigation also depends on the rainfall. Water will be stored during the heavy rains in ponds, lakes, or water reservoirs. Some water will get percolated into, and that water will be taken to the irrigation land. So, there will be perennial crops throughout the year, such as sugarcane, and there are usually two seasons. One is Kharif, K-H-A-R-I-F, Kharif season. Another is called the Rabi season, R-A-B-I. That is the seasonal definitions in the case of India. Usually paddy, rice cultivated, paddy cultivated 2 seasons. In rare cases, paddy will be considered for 3 seasons too. But in general, there will be 2 crops for paddy. Cotton, sugarcane, there are perennial crops. Then for vegetables, they have certain vegetables have certain seasons, they will grow. Accordingly, they will be cultivated and irrigated. The irrigation capacity of water, the irrigation capacity of water is called a duty. Duty is the irrigation capacity of water or a unit of water. How it is defined? It is the number of hectares that can be irrigated by 1 cubic of water. 1 cubic means 1 meter cube per second. So, number of hectares of land which can be irrigated by 1 meter cube per second of running water. So, unit of duty, usually duty is expressed by capital D. One way of expressing duty. Duty is expressed as hectares per cubic. Hectares per cubic. Another way of expressing duty is delta. Delta, as you have the notation delta. It is nothing but the total depth of water required for a particular crop. Total depth of water required for a particular crop. So you have to add all the depth of water you have been supplying to the agricultural land. Delta in M. Total depth. That is also one way of expressing the duty. In the case of tank irrigation, this delta is more pertinent, and in the case of direct irrigation system, the other first definition is. Duty can be expressed in terms of the total land, total area, hectares irrigated, total hectares irrigated, the area, cut, like that also you can express the duty. So, the duty is as per the area and the water requirement of the crop. The total period of watering required for a particular crop from the preparation of the land, such as plowing, leveling, for which you need water, from the preparation of the land till the last watering before harvest. The last watering before harvest is called the base period. This is called the base period. That is, you require water for preparing the land, then growing the crop. That is base period. That is the longest period. There is another period within the base period known as the crop period. Crop period means from the first watering, once the seed is sown, the first watering, seed is sown, to the last watering before harvest. That is called the crop period. And the first watering after the seed is sown, first watering after the seed is sown and the plant has grown little, a little. Plant has grown a little. It's called paleo, P-A-L-E-O. Paleo is the first watering after the seed has grown. So paleo, base period, crop period. All these things are required, and the intervals of water are very important for an irrigation authority to supply water through the irrigation canals. That is the significance of these periods. Once this is arrived at, according to the crop requirement, according to the command area requirement, the storage reservoir will let out water to the main canal. Main canal will let out water to the branch canals of distributaries, and the branch canal and distributaries will leave according to the requirement to the field channels. Field channels will supply water to the agriculture. So here the significance of hydraulic structures come. Now a student who is pursuing irrigation can appreciate the importance of hydraulic structures, because the hydraulic structures have to satisfy this duty and delta, this water requirement of the crop. starting from the dam to the outlet. Dam is the first thing, source, and outlet is the destination. So dam supplies water, may come through the canal regulator, may pass through an aqueduct, may pass through a canal drop, or a siphon well drop, or a direct sluice, or a tank sluice, then it will come to an outlet reaching the agricultural land. That type is the direct irrigation system. There are micro irrigation systems too, micro irrigation systems such as sprinkler irrigation, usually for vegetables, sprinkler irrigation and drip irrigation. That will save a lot of water. Wastage of water will be very less. One is called the drip irrigation. Drip irrigation means you have conduits, pipelines, usually PVC pipelines with the drip holes on them, equally spaced drip holes all around, by which they will just seep out water exactly to the root of the plants. So there will be small trapezoidal bunds on which we will be just sowing the seed and the plants will be going. Along the trough, when you have a piling up of soil like this, you have a trough on either side. You will be putting the drip conduits. You will be having control valves. Opening the control valves, water will spray into the plants and drip irrigation. If you just make it little elevated and just like a shower, if you supply water to the plant, then it is called a sprinkler irrigation. Sprinkler irrigation, a little more velocity will be there. That is possible when the plants have grown a little, just like rain, simulating the rain. Drip irrigation, the velocity will be less, but it will be continuous. So always the root zone will be wet. So it will go according to the osmosis of capillarity. Water will be sucked through the stem to the leaves and totally to the plant. The maximum depth up to which the root of a plant goes is called the root zone depth. Root zone depth. The significance of the root zone depth is, if the root goes, their water availability should be there. Then only the root can suck the water, take it away. So if the water table is low, as in the case of dry seasons, drought areas, you have to elevate the water table, by which the water table will be always touching the root zone depth. So the maximum depth to which the root can go, their presence of water has to be ensured by the irrigation system, either by natural means of rainfall or by artificially wetting the soil, elevating the water on the agricultural land. So agricultural land, the agricultural land is pervious, then only the roots can grow. So once agricultural land, it's going, water goes and takes the elevated water table, by which the roots always will be in a position to suck the water. This perviousness need not be misinterpreted with the impermeability of clay. I told you once, clay is better for cultivation than sand. So even now that statement holds good. Perviousness is with respect to the layer of soil below the clay. There will be clay, but there will be pervious strata through which water will get elevated. That is the best possible setup for good cultivation, good crops to grow and to get good yield. So that is called the percolation and seepage. Water percolates vertically, then seeps through the pores, then gets elevated, reaching the root zone. And naturally, how this takes place, this water cycle takes place, is known as the hydrologic cycle. The hydrologic cycle of the environment, hydraulic cycle of the environment, or generally hydrologic cycle. So what happens? You have sea, which has a surface, just like if you have a cup, you have a surface. Due to sun, with the high temperature, heats up the surface and the water particles are getting evaporated. They gets evaporated, goes to the sky, and they get condensed there. By condensation, they form clouds. Clouds are formed, and once the clouds are get condensed, they get densified and fall as water droplets known as rain. So this evaporated water goes, forms cloud, get condensed, drop down as rain, for which the plants and trees enable. That is called the transpiration. So transpiration is evaporation and transpiration. Transpiration is the breathing of trees and plants. So this gets, then the rainfall comes. Once this rainfall falls into the ground, according to the type of the soil strata, the water falling on the ground, a good amount will percolate into the soil. The rest of the thing will go as a surface flow known as the runoff. Surface flow known as the runoff. So hydrologic cycle includes runoff and percolation. This percolation will have a horizontal movement known as the seepage. So seepage increases the water table. Water table gets increased. So percolation, penetration in the soil, then seeping into the soil, elevating the water table. Runoff will also, again, whenever the water runs off, it will enhance the water level in open wells. It will enhance the water level in ponds. It will enhance the water level in reservoirs everywhere, even in rivers. Then it will go and reach the ocean. So from the ocean, water enters, gets evaporated to the sky. Transpiration also enables water to the sky. Then all these water again come back as rain, runoff, reaching the ocean or reaching the water carriers, water bodies, then enriches the soil with water due to percolation and seepage, by which elevating the water table. This chain, this cycle is called a hydrologic cycle. And hydrologic cycle keeps this water availability throughout our existence. So the global warming and climate change are the real threat to this hydrologic cycle. And felling out of trees, removing the vegetation, thick forests, right? All those things will tell very badly on the formation of the hydrologic cycle or the continuity of the water chain. So that It is a thing which should be taken care of, by which there should not be any break in the hydraulic cycle of the chain, water chain, or the water movement as hydrologic cycle. Then you have rainfall and runoff. So the runoff or the flood will be measured using hydrographs. Hydrographs are pictorial representation of the surface runoff. And rains are gauged or measured. Rainfall is measured by rain gauges. Manual measuring by one very typical rain gauge measurement is Siemens rain gauge. Siemens rain gauge will be a bottle-like thing. There should be the rain where you are measuring the rain gauge stations should be open without any barriers, and it will be fenced properly at a greater distance, and no obstructions will be there, by which the water will get collected in the bottle, specific bottle, and the rainfall will be expressed in terms of mm. You have automatic rain gauges also, tipping bucket type. So that it automatically gets the rainfall and it will be marked in a graph sheet. So you can readily get, it's a ready reckoner of knowing the rainfall at any period of time. So rain gauges, there will be specific stations and norms for the stations to be used as a rain gauge measurement locality or point. So rainfall will be measured, runoff will be measured, and all these correlations are required for planning a perfect irrigation system. So we are trying to wind up another major primary discipline of civil engineering known as irrigation engineering and hydraulic engineering, now named as water resource engineering. Water resource engineering. So we have seen transportation engineering and now the water resource engineering. Thank you for watching these two. Let us see what we can do tomorrow by God's grace. Thank you very much. God bless.